In example 4, we have 3 different techniques we can apply in order to simplify what would be otherwise unnecessarily complex expressions. So the first technique we're going to look at is rewriting. And so they've asked us to find the antiderivative of 5e to the t plus 1 over cosine squared t dt. And so I'm going to rewrite this. Now honestly, I don't have much of a problem with 5e to the t. And the reason is we just found the antiderivative of e to the x only a few minutes ago in a previous example, but the 1 over cosine squared t just looks too hard. But this is a reciprocal. This is the reciprocal of cosine squared. And so if you think back to your trig identities, the reciprocal of cosine is secant. So we could rewrite 1 over cosine squared t as secant squared t. And I like to go ahead and put my entire integrand in parentheses just so it's perfectly clear what's going on and that the differential applies to both of these terms. Alright, now integrating, or rather finding the antiderivative, the antiderivative of 5e to the t is just going to be 5e to the t. And now I have to think, what do I take the derivative of in order to get secant squared? And if you look back at your rules for derivatives of trig functions, you will find, or you may recall, that the derivative of tangent is secant squared. So tangent t, and we're going to add our constant of integration. Now let's look at our second example. Here we have find the antiderivative of quantity 3x minus 1 squared dx. And so one thing that we can do is multiply or distribute in order to get a polynomial. And so we could certainly rewrite this as the definite or the indefinite integral of, and let's see, so applying this rule, the perfect square trinomial rule, a minus b quantity squared is equal to the first one squared minus the product of the two doubled plus the last one squared. So applying this rule, we can do this very quickly. 3x squared gives us 9x squared minus 1 times 3x is negative 3x doubled is minus cx, or 6x, sorry, plus negative 1 squared is positive 1. We'll put that in parentheses and give it a dx. Now we can integrate this, or find the antiderivative rather, of this polynomial using the techniques that we saw in the previous examples. And so we have 9x to the third divided by 3 minus 6x squared divided by 2 plus x to the 1 divided by 1 plus c. And so simplifying, we have 3x cubed minus 3x squared plus x plus c. Now the third trick they tell us is to, if you've got a rational expression, sometimes you might be able to split it up into a sum of different fractions. And so we could do this by dividing each term by x to the fifth, and what we would get would be find the antiderivative of x to the second divided by x to the fifth. That's going to be x to the 2 minus 5, or x to the negative 3, plus 4x divided by x to the fifth. That's 4 times x to the 1 minus 5, or 4x to the negative 4th, plus, and 5 times x to the negative 5th, and dx. And so raising this power, we have x to the negative 2 divided by negative 2 plus x to the negative 3 divided by negative 3. Pardon me, that should be 4x to the negative 3 divided by negative 3. and then plus, and this is x to the negative 5, so that'll be 5x to the negative 4 divided by negative 4 plus c. And so let me just come down here where I've got some more room. And this will be negative 1 over 2x squared minus 4 over x cubed minus 5 over 4x to the 4th plus c.